Formula One car is a constantly evolving prototype that needs to be upgraded on a race-by-race basis.
The objective of Formula One is to try and be the quickest, or at least be on par with all your contemporaries. You're always looking for what can make that small difference. So we're always looking to chip away at the weight, the performance, the overall packaging. The challenge is always time and pressure.
A Formula One car is largely made of composite material. We produce more than 4,000 components every year. Many of them have very complex shapes.
When we're looking at a composite material, one of the big advantages is you can use different plies of carbon with different properties to get the most stiffness for the minimum weight.
You've got tens or hundreds of pieces of material, everyone optimised structurally and positioned carefully to do something that's very deliberate and very controlled. That obviously increases the complexity, the cost, the manufacturing time, which is where we fall back on things like FibreSim to help us process that through the manufacturing and design cycles. Traditionally, handmade composites, by the nature of being handmade, have got a level of variability. Variability isn't really acceptable in Formula One.
FibreSim is much more automated and it allows us to control how we design our composites. So it allows us to detail very much how we're going to lay up the composites and the detail of how we do that. So when you know you've got good control over the parts, then that means you can make them lighter, you can play around with stiffnesses a bit more, and you can really get a lot more out of your development.
Formula One is at the leading edge of technology in many areas.
The level of data we need and the control and precision we need and repeatability of what we're manufacturing, FibreSim is the only solution that we can viably see that would help us do a contemporary Formula One car. We need to understand stress engineering, we need to do design for manufacture, and then we need to do the physical manufacturing. Three very different disciplines with different methods and procedures. FibreSim helps us bring all those into a single source. We have a single solution that works across the departments. We can use FibreSim spread between design and manufacturing to look at drape simulations, look at how the fibres work and understand how best to optimise each individual ply of material together so there's no surprises within design or manufacture when we're producing the finished components.
We've got a really big regulation change, so the cars are getting wider, all the bodywork's changing, we've got a lot more freedom on aerodynamics, and that's really tough because the loads on the car have gone up a lot, they're going to get a lot quicker, and again that's more focus on the composite parts, they're going to have to be stronger, we still want them to be light. It's a really good challenge and it's going to push all the technical areas hard. Using FibreSim when we've got a big regulation change like that is super useful for us because it does allow us to have that control on the parts and it allows us to develop those new laminates knowing that we're going to have good control over what we do.
The partnership with Siemens is perhaps one of our most established and the best demonstrator of what technical partnerships can achieve.
Siemens had truly become part of our family. It's unthinkable to think of our operation without this relationship. That is not just technical and engineering, it's also a human relationship.
Technical partnerships are very important to Renault Sport Formula One because our technical partners do have the knowledge and help us develop and help us drive the team forward.